Welcome, Python learners. In today's video, you're going to master Python tuples, learning how to create them, access their data, and understand why they are a powerful, unchanging tool in your coding arsenal. Ever needed to store a collection of data that shouldn't accidentally change? Imagine storing exact geographical coordinates for a map, specific RGB color values for a design, or even a user's immutable profile details like their ID and date of birth. If you want to keep that data fixed and safe, Python's unsung hero, the tuple, is exactly what you need. So what exactly is a tuple? Think of a tuple as a list's cousin, but with a very important difference. Tuples are ordered and immutable. Ordered means the items are stored in a specific sequence, just like in a list. You can access them by their position, also known as their index, but immutable is the key. Once you create a tuple, you can't change, add, or remove its elements. It's fixed, permanent data. This makes them super reliable for data that should never be altered. Creating tuples is straightforward. The most common way is by using parentheses and separating items with commas. Theory: create 1. My tuple equals 1, 2, apple, true. Print my tuple. As you can see, my tuple holds numbers, a string, and a boolean. Tuples can hold items of different data types, just like lists. Interestingly, you can sometimes create tuples without parentheses, especially when packing values. This is called tuple packing. Theory: create 2. Another tuple equals 10, 20, hello. Print another tuple. Python automatically understands that 10, 20, hello should be a tuple. A crucial point: if you want a tuple with just one item, you must include a comma after the item. Without it, Python treats it as a regular variable inside parentheses. Theory: create 3. Single item tuple equals 5. This is a tuple, not a tuple equals 5. This is just an integer 5 in parentheses. Print type single item tuple. Print type not a tuple. Notice the output. The one with the comma is a tuple, the other is an int. Don't forget that comma for single item tuples. And finally, an empty tuple is just empty parentheses. Theory: create 4. Empty tuple equals empty parentheses. Print empty tuple. Accessing elements in a tuple is exactly like accessing elements in a list or a string. You use indexing and slicing. Indexing starts from 0 for the first element. Theory: access 1. Colors equals red, green, blue, yellow. Print colors 0, first element. Print colors 2, third element. Print colors -1, last element, using negative indexing. You can also grab a range of items using slicing. Remember, slicing start-end goes up to, but not including, the end index. Theory: access 2. Numbers equals 10, 20, 30, 40, 50, 60. Print numbers 1:4, elements from index 1 up to, but not including, 4. Print numbers 3, elements from start up to, not including, 3. Print numbers 3, elements from index 3 to the end. Tuples support many familiar operations. You can concatenate them, which means joining 2 or more tuples together to form a new tuple. Theory: ops 1. Tuple 1 equals 1, 2. Tuple 2 equals A, B. Combined tuple equals tuple 1 plus tuple 2. Print combined tuple. You can also repeat a tuple by multiplying it by an integer. Theory: ops 2, my pattern equals x times 3. Print my pattern. Getting the length is simple with the len function. Theory: ops 3. Data equals 10, 20, 30. Print len data. And you can check if an item is in a tuple using the in operator. Theory ops 4. Fruits equals apple, banana, cherry. Print banana in fruits. Print grape in fruits. For tuples containing only numbers, you can easily find the min, max, and sum. Theory ops 5. Numbers equals 5, 1, 9, 3. Print min numbers. Print max numbers. Print sum numbers. This is the most crucial part about tuples, immutability. It means you cannot change elements after the tuple is created. Let me show you what happens if you try. Theory error 1. Coordinates equals 10, 20, 30. Let's try to change the first element. Coordinates 0 equals 5. This will cause an error. Print coordinates. And boom, you get a type error, tuple object does not support item assignment. This is Python telling you, hey, you can't change this tuple. This error is a feature, not a bug. It protects your data from accidental changes. If you need to change the data, you should probably use a list or convert the tuple to a list, make your changes, and then convert it back to a tuple if necessary. So with all this talk about mutability, when should you choose a tuple over a list? Use tuples when you have a collection of items that should not change. Think of fixed coordinates, database records where fields are static, or credentials. You want to use the collection as a dictionary key. Lists cannot be dictionary keys because they are mutable, but tuples can be. You're dealing with heterogeneous data, different types of data that logically belongs together, like a person's name and age, where the combination itself is fixed. You need to return multiple values from a function. Functions often return tuples by default if you return multiple items. Use lists when you need a collection of items that will change frequently, add, remove, modify elements. The order matters, but the items themselves are mutable. This marks the end of our first lesson on tuples. In the next video, we'll dive into hands-on coding, explore tuple packing and unpacking, and apply what we've learned to a practical project. Make sure to check the description below for all the resources related to this lesson, code snippets, a quiz to test your knowledge, and key takeaways. Hit that subscribe button so you don't miss the next video.